Okay, in 7.2, it's going to be very similar to 7.1, except we are going to have a target. So instead of just simplifying an expression, we will be verifying an identity. All right, so you can see here in this first example down below that top box, we have an equation instead of an expression. All right, so the general guidelines for this, we will only be able to work with one side of the equation, and generally speaking, we'll want to work with the more complicated side first. All right, step 2, we look for opportunities of what we did yesterday: factor, add fractions, square a binomial, multiply by the conjugate, create a monomial denominator. So we want to try to get one side of the equation to look like the other, and those are the methods that we will utilize. All right. If you can use fundamental identities, primarily your reciprocal, Pythagorean, and quotient identities for now, that will be the way to go. And then one method that we will utilize towards the end, if nothing else works, is convert everything to sines and cosines, all right, which we do have the ability to do with our identities. All right. So for this first one, which side would you say is more complicated? The left side would be more complicated for sure. So we look for a way to make that left side look like the right. And as we talked about a couple minutes ago, we have secant squared theta minus 1, which could be what? Well, we have a combination of secant squared and 1, so which identity could we utilize here? Right, we could utilize the 1 plus tangent squared, in this case theta equals secant squared theta, but we just have to rearrange that Pythagorean, okay? So if we rearrange secant squared theta minus 1, we can rewrite that as, if we rearrange the Pythagorean that involves that, we can rewrite it as tangent squared, right? Okay, we can just move the 1 over, and that will become tangent squared. So just to give the visual of that, we can move the 1 over, and that'll give us secant squared theta minus 1. So we can replace secant squared theta minus 1 with tangent squared theta. Cool? All right. So this will be tangent squared theta over secant squared theta equals sine squared theta. Okay. Any questions so far? All right. From there, we need to get tangent squared over secant squared to become sine squared, and that's actually not going to be too terrible. All right. If we take this secant squared theta and move it up to the numerator, it becomes what? Cosine. Yeah. It'll become cosine, right? If you take a monomial term, all right, and you move it from numerator to denominator or denominator to numerator, it will become its reciprocal. So we can rewrite this as cosine squared theta times tangent squared theta. All right, and again, we're just going to work with that left side. We're going to try to make it become sine squared. All right, we're not quite there yet. There is an apparent reason. Yes. Right, when we move that up, it becomes multiplication. Okay. And then to finish that off, the issue here is on that left side, we don't have a sine squared at all, right? So we need to come up with a sine squared somehow, all right? And one way we can do that is with the tangent squared, all right? We know that tangent theta using our quotient identity is equal to the sine over the cosine. So if we have tangent squared, that will be equivalent to sine squared over cosine squared. quotient identity. Have your identity sheet out. That's the quotient identity. And now, since we know that tangent squared is equal to sine squared over cosine squared, what happens to the cosine squareds? They cancel out, and we are just left with sine squared theta. So we would have sine squared theta equals sine squared theta. That identity is verified. I'll just put a check. So you could write out sine squared theta as you work your way down, or you can just draw an arrow down at the end. Okay. Any questions on that?